Okay, let me introduce you. This is our podcast show named ThinkTech.
Yes, yes.
Uh, here we talk about technological stuff and all researcher stuff. So, you are the first, actually, the second guest, first industrial guest.
And how you start your initial phase of your career kind of stuff. Can you
So,
give some intuitions on it?
oh, definitely. So, this is a very, very long and a very, very broad question. I can do a full podcast on this at this point. And this is the most asked
Okay.
question. Uh,
Okay.
so broadly speaking, like my journey in machine learning was not a very conventional one. I got into machine learning very indirectly, to be very honest. So I started programming many, many years ago. I started programming in 2007 when I was very, very young, when I was in primary school. And
Okay.
for me, there is this, for me, like, getting into technology, like there are two important aspects which play an important role in life, right? So
Mm-hmm.
the pehla aspect hai, that is the passion you have and something you can innately generate, like the passion, how much work you want to put in, how much you like things. And so दूसरा aspect है, that is basically the family background. तुम्हें basically कैसा घर मिला, क्या तुम्हें, what aspects of family life you got, what exposure did you get in your life, right? And I think
Mm.
for me, both of them walk hand in hand. And like, so one of them is slightly under your control, and the other is completely not in your control. And so for me, what I was always encouraged to pursue stuff in my life, and I myself was really, really, I was a very motivated kid growing up. Wanted to try to understand the world, try to see how things work, and like I got it really, really interested into physics, and then gradually got really, really interested in mathematics. And mathematics ke baad, the next logical step was definitely computer science. And for me, like I started reading a lot of CS stuff, like because I had a good background in mathematics. And before like I properly got into CS, like I had a life in mathematics where I published papers in mathematics, I conducted mathematical
Okay.
research, I have given like TED talks, I was invited to conferences. And I mean, I still do a lot of mathematics. If you see my blackboard, it still has some
Yeah, yeah, yeah.
I do
Yeah.
math, still today. But like more than that, I feel it is. I mean, I started like I got into like conventional image processing right around 2010, 2012, and that is where all these nice papers like LXNet were basically released. VGG, LXNet, all the initial papers were released, and I remember being in my 10th board exam trying to get into read these papers. Like it was like that time of my life. And beyond that, uh, basically after that, I basically Google released TensorFlow, and like there was Chainer, there was Theano. Like the early days of deep learning were very, very different. Like the only thing you had was import NumPy as NP, and that is where you started whatever you want to start after that. Like
Yeah.
unlike now where you can do make fancy generative AI in like 10 lines of code. All what you could do is just import NumPy as MP. And like from there on, like I got into like I was really, really wanting to do more applied like stuff. So I did a lot of theoretical math, theoretical CS, and I wanted to do more applied stuff. So doing something applied was the next step. I did a
Mm.
lot of development over the years, like a lot of desktop development, web development, all of those. I still do that. But then I realized that I want to do something core, something more scientific, and I did a lot of scientific computing. I was one of the people who broke world records for pi and things, computing pi to the long decimal digits and stuff like that.
Okay.
I gradually got into machine learning. I did a lot of projects. I started applying machine learning in what I used to do before, which didn't have machine learning. And then I had a huge open source community already set up before I joined college. And so 2016, that was the situation when I joined college. 2017, I was invited to MIT uh, because of
Okay.
the community and the contributions I had made good collaborators. 2017, I did more applied ML. I was invited to Caltech for the summer, where I did machine learning and biology, deep learning and biology. After
Mm.
that, I was invited to Mila, which is one of the top institutions in the world outside of the US, where I was invited to speak on. Um, Not speak on, but like to work on climate and AI, as I did reinforcement learning in climate.
Mm-hmm.
And beyond that, I was at Cambridge after that, where I did deep like learning plus philosophy. So that was a very interesting combination of like combining computer science and combining philosophy. So I've been doing a lot of applied stuff. And for me, I think machine learning is one tool I have in my toolbox. Now, it is a big tool. It is a tool I use very often, but it is a tool, one tool I have in my toolbox.
So as you said, you have made so much contribution. So you have made so much contribution before coming to the college. I
Yeah,
just am shocked. So many of the
oh,
students are
I
not contributing that much, and that is a pretty impressive thing, I would say.
I mean, that is once again like the less about what I did or how I have, but more about like the society and the world we live in. Like,
Hmm.
I definitely was my like growing years were the same years which corresponded to the growth of the internet. I was very fortunate to have internet very early on in my life, and the internet was being developed, and I had a pivotal role. I was one of the early members of Stack Overflow, one of the early members of, like,
Okay.
I used to consume a lot of YouTube when it just came out, like in terms of like mathematics YouTube, physics YouTube, and those things like that. So I think I got a huge. I did linear algebra, calculus when I was like 9, 10 years old. And if you look at world history, there can be many. There are like, I'm not a genius. Like, I just got exposure to these things. Like, there are greater geniuses, far greater geniuses in world history who could have done it when they are maybe
Hmm.
5, but they did not have the mechanism to get exposed to those things, right? So
True.
they had
True.
to do it when they're 15, right? So I think I was lucky enough to have the mechanism in my lifetime where if I wanted to study linear algebra, I didn't need a teacher. The computer could, like, YouTube could teach a 10-year-old linear algebra. So I think
Yeah.
that
Yeah.
is more on that
Because,
than any.
yeah, because because of internet, there are now I can see many YouTube channels are going on mathematics, on physics, or on computer science. They are teaching lots of stuffs. So as you have said, you have most impressive mathematical background also. So many are the students that is jumping into the computer science, but they are not having that core or much mathematical background. So can you explain to our those audience like how much the
and
importance of math it is in to be
and yep,
in machine
also
learning era.
and
Yeah,
also with
Sagar.
that extent, can you suggest some good website or some online material from there they get a help for learning?
In terms of knowing mathematics and applying mathematics in computer science, let me take that question first. So the so the challenge we have here is that we basically have a certain education system where you're exposed to a certain level of mathematics, and you have a certain comfort level in mathematics, and then you basically switch to computer science, and then you're pressured to basically do competitive coding and find a job. And I think all that is super important. Like, the entire pipeline is very, very important. However, there's two types of computer engineers you can become. One of the computer engineers is somebody who really likes to build things from scratch, somebody who likes to make these machine learning algorithms, somebody who likes to develop things from scratch, tries to understand how things work, and gets into the positions like applied scientist, machine learning engineer, maybe like even like strong deep software engineers, high performance computing engineers, like those positions, right? So if your aim is to get into those positions, if you feel you are passionate about those kind of things, and you want to really, really build things, you really, really like the engineering aspect of things, then I would say mathematics is extremely crucial. And in your engineering journey, be it your bachelor's, be it your master's, you have to emphasize a lot on mathematics. In mathematics, definitely calculus, multivariable calculus, linear algebra, like, it feels very, very underrated, but nowadays it's very, and also have a strong background in statistics, a strong background in optimization. So all of these things like multivariable calculus, linear algebra, statistics, optimizations, these things build on one another, but I think these are super, super fundamental and super, super essential if you want to get into those roles. However, there is a large class of computer engineers who do not want to get into like these kind of positions.
Hmm.
What they want to do is they want to use tools these people build and build like good user experiences. They want to become, like, have like very robust, scalable cloud systems. People who want to manage servers and like all this, a million other things you can do in computer science. Where I think more of it's important to know what these people are making, have a good understanding of that. But the important thing is the application and the usage of that. And if you're aiming to become somebody like that, then my basically goal, my suggestion is to, yeah, have a good understanding of mathematics, maybe high school and university level mathematics, but then have a much more broader, have a huge breadth in whatever you pursue, right? And whatever you do, have a huge breadth in your approach towards learning computer science, and learn as many technologies as you can, learn as many tools as you can, learn as many frameworks as you can. That is going to be more important than mathematics. So you have to decide depending upon where you want to go and where you want to pursue. If you want to become that fundamental person who builds things, yes, the pay and everything might be slightly higher, but there are far less jobs than the jobs as somebody who applies stuff, right? So one person makes a TV and a billion people watch it. It's always like that. The people who make things are much smaller in number than the people who consume them, right? So there's that divide. You have to figure out whether you're competing or where you want to go, right? Depending upon that, you make
Sorry, that's a nice intuition we get from your conversation. So, can you share one turning point of your life, and then you just decide that I want to do a machine learning?
there was never a turning point in my life like that I decided I want to do machine learning. In fact, there is no
So
turning.
you was already cleared you want to go to this path.
Yeah.
No, 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 no. That is exactly what I'm trying to say, and that is exactly what I want to,
Hmm.
even talk to the listeners that, I wanted to do computer science. The goal was much about like using ideas in computer science and applying it to the world, applying it to healthcare, applying it to climate science, applying it to agriculture, applying it to making this world a better place to live in. And machine learning became famous. There were like good techniques and good things developed. There were class of optimization problems which you couldn't solve through any other methods, which we can now solve through machine learning. So machine learning is a tool you have in your toolbox, right? Like a lot of other tools you have, right? So there is nothing like, I want to just do machine learning. You can't just do machine learning. There is a lot more engineering and a lot more other things that happen beyond, before and after the machine learning aspect. Machine learning is just one tool you have in your toolbox to solve the problem in hand. So I think the more important thing is the problems society faces and how you can solve them. Then actual any computer science is a tool, machine learning is a tool. These are all tools. And today that there's people talk about machine learning and LLMs and everything is all the rage. Maybe 5 years down the line there's something completely different, and 10 years down the line people just have to go to dictionaries to figure out what machine learning was. You need to go to Wikipedia and see what machine learning was, right? So I am quite bullish about machine learning and its future, but like it's not like it's I feel it's just a tool in your toolbox, and you need to treat everything that way. And you know you you pursue solutions to problems and not individual techniques. So rather than like taking out machine learning and say, okay, where I can I apply this, the right way of thinking about this in my opinion is to look at questions and say, okay, what can I apply to this, right?
Yeah.
Okay, so can you tell some promising areas of machine learning which are going to significantly impact the coming years?
So definitely, it's always like it is the hardest thing to do is to predict the future, right? That is always the hardest thing to do. But
Yeah,
I can still
that is what machine learning engineers do now.
oh yeah, I mean, machine learning
In
engineers
terms,
try to predict the future, and yeah, that's true. So I mean, we can make a good bet on what is going to be super
hmm,
important. One of the key things is looking at the engineering aspect of machine learning, which I really emphasize on. Like bachelor's and master students in India and across the world basically have limited exposure to, like, all what you do is basically make handwritten digits to see who survived in Titanic and who did not survive, and all of those toy projects, which are very important. Mind well, they are super important projects, but like the real problems and the real challenges are on scalability. The real challenges are not about like importing keras and making a neural network, but talking about how do you have if you have a neural network, how do you deploy it to a billion people, and how do you make sure that you have availability, consistency, fairness, and you how do you do that? Those are like hard, important, impressive problems. Those are the kind of people, and those are so you need a huge infrastructure for things like that. You need good understanding in scalable systems, in ML ops, ML versioning, like the so if you choosing between machine learning and software engineering, the generic advice is to choose engineering, because engineering is more important than anything else. Like, you have to engineer any system. So I think it is, quite. It's so that is the most important advice I would want to give you. That in
hmm,
that respect, like the entire infra part of machine learning ops, like things like that, around the actual, because model development now has become the easiest thing. Like, anybody does model development,
true.
and like there's already good models developed from these top AI labs which have good GPUs and TPUs and everything.
Hmm.
What you have to do is to deploy them, and so, but still, what people are getting expert into is people are getting expert into model development and not deployment. Will never
Yeah,
need. developing those models. There is like the disparate between the top labs and the resources they have to develop models and any other organization is huge. So you
Huge
always have
difference.
to take
That
a model,
yeah,
you
yeah.
find it, and then scale it and serve it, right? So that is
I,
first thing that
hmm.
that is gonna quite be good. Like broadly in machine learning, of course, explainability is doing very well. Machine learning fairness, ethics in MLAI is one domain which is doing really, really good, and I think it is gonna remain doing good because you talk about how do you make sure that we are inclusive? How do you make sure that when we walk, we take everybody with us, not a few select communities who are always been privileged throughout history. The So that is a good sector where you can essentially focus on. Other sector is of course like the entire LLMs, and like how do you have generative models and how you have good generative models which generate not only text but generate images and who generate maybe videos, and so basically overall generative AI, and where you can use that generative AI and seamlessly integrate it in an ethical moral manner, like AI policy, AI law is going to come in here, and then the engineering aspect is going to come in here. So how do you build large scale, scalable generative AI pipelines, which are beneficial to humanity at the large scale? That is a very nice and open problem. Of course, ML security is another open problem. Low
Obviously.
latency, like like low resource machine learning, edge machine learning is another problem. Like how do you look at quantization, and how do you make sure that if we were able to ensure that there is phone in hands of everybody, right? And then now we are basically almost ensuring that everybody has internet. And now how do you make sure that everybody at a local level, from whatever phones or whatever device they can have personalized machine learning? The other like good the other area is essentially the what connects to this is like privacy in machine learning, and like looking at differential private machine learning systems, which are like you would give you want to give very, very limited amount of data, but you still want really high quality predictions. Like how do you have that trade-off going on? So these are like really interesting areas which are potential.
Okay. As you said, the MLOps is currently a new technique, and it is also unseen by the many developers right now or the many young students. So there is a common misconception, or I can say the confusion among the people like DevOps and MLOps. So can you clarify that?
And yeah, just starting the question, like, can you please explain the what is the main difference between a traditional programming and machine learning programming? So,
I mean,
can you?
once again, that is what I've been telling, that there shouldn't be much, but the fundamental, I think the way you iterate. So traditional programming, I mean, it's like machine learning is a part of traditional programming. I mean, the machine learning is nothing special. Like like you program a system which basically has these models which learn themselves. But essentially, the way I think, let's say you want to develop a website, or let's say you want to develop an app, or let's say you're basically writing backend for some service, or let's say you want to write a like some ingestion pipeline for something. The the way it works is that you let's say that there is a lot more agile development methodologies usually used in like proper software engineering systems, where things are like there are tickets, there is storyboarding, and there is a lot of like iterative development that happens. And then everybody contributes something to so there's a lot of parallelization, there's a lot of agile you can do in conventional like traditional software engineering pipelines. When you have things like machine learning models, especially when you care about the quality of these machine learning models, the actual challenge there is about iteratively making the model better, and that is much more sequential task than parallel task. So you can have multiple ideas on one models, and then you would want to see how the model improves in quality. And then there are two people, and then when you combine those ideas, they might like basically not be giving incremental gains to your project. So it essentially is like if you do change A and change B in software engineering, you can then somebody needs change C, which is the combination of A and B and C. And so it's A and B, and so you have a nice like effort of A and effort of B, both of them are assimilated into the system. However, as a machine learning engineer, if you do effort A and effort B, if you try to combine them, maybe the none of those efforts essentially end up in the system, or just one of the efforts ends up being the most important, and that gets. So there's a lot of work, there's a lot of iteration, there's a lot of like more waterfall element to machine learning development than the agile methodology. So I think that is the the main difference. And I think question about like ML ops and DevOps, I think DevOps is much more general. DevOps takes auto scaling, containerization, this entire CI/CD pipelines, and for so basically for a machine learning engineer, they would make models, they would serve models. And ML ops would basically work with data engineers, they would work with DevOps, they would work with data scientists. So and they'll basically do DevOps in a machine learning context. So they'll then talk about like the understanding the model quality, trying to just do the scaling, containerization, everything, but like also have this feature engineering, data preparation, processing the entire pipeline process. If there is an active learning component, they'll basically ensure that the active learning happens and nothing is broken. And this will be essentially the ML ops would look into any non-functional requirement you have for your machine learning pipeline and try to solve and ensure that the non-functional requirement is met in the machine learning development pipeline.
So, as talking to MLOps, and so as you said, continuous model training is also an important part today. So, I have come across the term that is called data drifts and the model drifts. So,
Mhm.
can you explain this to our audience also in
Oh
easier
yeah.
and simpler manner,
So it's a very simple thing.
and
So let's
also
say
how to encounter these problems if possible?
you encounter these problems in the wild. You don't need to go find. I mean, the good question would be how you solve
Yeah.
these problems. Not maybe even you encounter these problems in the wild. So
Hmm.
talking about like data drift and model drift, like it's very simple. Like you like in any big company or in any organization, what happens is that you have some sort of a machine learning model which makes predictions, and like it continuously trains on data, because as the users, we are collecting data at an incredibly large pace. So every single day, let's say you wake up and you basically to interact with the phone, there are these companies who are collecting whatever you want to collect. You there, let's say they're interacting with your app, and then you're just collecting data. So you basically have this incremental understanding of how this person and whatever interactions and whatever data sets you have. So if you have a machine learning model which makes any prediction, you need to basically just if as the new data comes in, the model needs to train. Now, in data drift, what happens is essentially the data which comes has some sort of a great shift than whatever the model has seen before. And like so, let's say for example, you assume like certain sort of behavior, certain sort of data values and stuff like that, and suddenly like all your users, something happens, or something happens to your app, or something happens anywhere, like, and all your users will try to have the distribution of data which your model then starts training on is very very different than the what you basically expect or what the previous data was. So that is basically the problem of data drift, and this does happen in a lot of production quality systems. And it happens because maybe the user behavior drastically changed. Maybe there's some library or something in the middle you're using to collect data, or like have things that change. Maybe you're not able to load balance. Maybe you're basically dropping queries. Like there's something that has happened in your pipeline to collect data,
Or
or then
maybe some unfortunate situation like COVID-19 just came
Yeah.
out of nowhere.
that is another, yeah, that
Yeah.
is another, like what if similar something has happened at the user level or
Yeah.
world level, which is a very rare incident, or something that
Mm,
has happened at your own or your own internal system.
obviously.
That is essentially it. And model drift is, so whatever you did to the input, that happens to the output. That the data and all is reasonably good, but like something happens to your model, and the predictions the model is making is very very different than what you were expecting. Like maybe like let's say you have like your continuous stream of data training, you have a continuous stream of predictions, and that continuous stream of predictions somehow ended up not being correct, and that usually has some model calibration issues, or like the model not being stable is a very standard cause of those things. And then we look at these models, you try to improve model reproducibility, you debug the models, you try to see quantization, you try to see where there is these things happen, you try to train on old data, and then maybe you get better with it.
Yeah, so if we are talking about training a data kind of stuff, so there are some fascinating algorithm or concept here you want to share
Mm.
with us.
uh, I mean, in what sense, like
Like
Uh,
to you, which algorithm or concepts is more fascinating towards you? Like you heard about that thing, that concept or methods or algorithm, and you feel, oh, I love this and I want to do anything in this.
I mean, like, so once again, this depending, so there are a lot of things available in the market, and depending upon your size of the data set, depending upon, the scale at which you want to deploy systems, I mean, you make those choices, right? And I think there is no one problem that one solution that fits all problem kind of a situation here. You need to actively be making choices. Like, you, once your project starts, you need to understand how your data is and how what's the scale of those data, the data, and like what kind of anomalies do we have, like do we need some pre-processing, like you have that thing in mind, and then you make a decision. And then eventually you also closely monitor how your system is evolving, and if you see things like these model drifts and things like that, you realize that maybe now the model I'm using is not enough for the amount of the volume of data or the kind of data I have, and then you basically change your decisions, and then you actively are in a process of iteratively making your system better and better, the new data that comes in into the place. So like, I personally don't feel that there is one method or one particular thing I would want to highlight, because like depending upon your question, depending upon the question in hand, and depending upon where you are in that question, solving that question right now, it would basically.
Yeah.
Okay.
Okay. So, like you say, what kind of question we have into our hand, based on that we actually select an algorithm or concept. So, can you please share some your collaborations or your experience with the MIT, Stanford, and ThinkTech, where you solve the real one kind of stuff, and there you implemented that concepts.
Yeah, and this could inspire many young professionals also to buy these projects.
Yeah.
I mean, so I did like reasonably interesting projects when I was there. Like, when I was at Caltech, I did deep learning applied to biology, like cell biology. And so what we did was, like, let's say we have like fluorescence mic we have fluorescence microscopy images. So fluorescence microscopy is this way of like doing like cell microscopy. And let's say you have a constant video feed of fluorescence microscopy, and what we wanted to do was like do real time cell segmentation and cell tracking. And
Oh.
2018 and stuff, there was no transformers, were almost, I think transformers were not invented when I did these projects.
Hmm.
And so we basically used like mass RCN and a lot of other techniques which were like state of the art back in the day. We now have much fancier methods, but like which were like state of the art back in the day to do the segmentations used. Also like got a lot of inspiration from conventional image processing, like the watershed algorithm and your deep watershed, and like a lot of those methods we used to essentially have these and train these models. And it really and then we once we basically were able to get these predictions, we realized that yeah, this is definitely not real time. We are getting good quality, but definitely this is not real time. And so we retrained these models and fine-tuned and quantized these models, looked into quantization, looked into making them real time, and finally were able to get a method which did like reasonably good cell tracking in real time. And the library I worked on is this library called Deep Cell V2, which is quite openly available on the internet.
Hmm.
So my project at Mila was quite an interesting project where we did like apply machine learning, like agent-based reinforcement learning to like climate change, and trying to, so we basically model the climate and the economy, and then there's something called these integrated assessment models where we have climate affecting the industry and the industry through emissions affecting the climate. And so there are these models of, if you have a lot of industrial growth, you basically are going to damage the climate. And how do you, but if you don't have industrial growth, people are gonna die of hunger. So you
True.
basically need to give a good balance of these, both of those aspects. And so we used reinforcement learning to understand policies and model agents where you could.
Okay. Talking about MIT, and you're currently at Google. So the next booming thing in the computer industry, I guess, is quantum computers. So
Sure.
yeah, so how you see machine learning future in the era of quantum computers?
So I think so quantum computers, we're still very, very far away from a full
Hmm.
large scale quantum computer where we're gonna we do any machine useful machine learning on that, right? So I think we're very, very far away, and it is, as I said, it is the hardest thing is to predict the future. However, we can have a reasonably good understanding of that. So what ends up happening, see, I think so what is going to end up happening is that uh, training and inference pipelines, I think through compute come through the training is going to become much more easier, is what I feel, through quantum computing. And then when we basically will be, if you will be able to have large scale quantum computers, maybe handheld quantum computers, then like the idea of personalization, the idea of training really really large and complex personal at on the spot data, data patterns is going to be easy. So we're going to have very very robust and very very adaptable machine learning models right off the bat. And whether it's a good thing, whether it's good for society, not good for society, what are the ethical implications of that, is always questionable. Like, and the Shor's algorithm, if you look at, like, the RSA, like quantum computers breaking RSA and things like that. So there's always these things, but I think there'll always quantum computers will pose these threats, will give us a lot of benefit, and then there'll be other people who will make algorithms which are basically not.
I also guess in the quantum computer era, the machine learning will also change because currently we are working with zero or one bits. So, but
One
in the
binary
yeah,
bits.
in quantum computers, all these things
Yes, two
definitely
bits.
changes. So, I guess all the algorithms will definitely changes. So,
No, I think the spirit
yeah.
of the algorithms will remain the same, but the way we train and the way we build like engineer
Hmm.
systems are
Okay. So, can you tell our listeners how do you get motivated towards your research? Like you have to do the research and make something
So
in
I
that
think
something.
my philosophy on that is super simple. Like, I think you pursue things which you are really really motivated about. You always have a question you feel you really want them to solve, and then make that
Yeah,
your
yeah.
research. Right. So I mean, you pursue, you put your effort and you put your energy in something you are incredibly passionate about. And I think the passion comes from within to understand this world. We it's just like as Sal Khan put it in his MIT commencement speech, that we are like, we don't know why we are here, but we kind of like the mystery of it all. And it's just we just trying to explore, we're just trying to, and like we might not even know 0.0001% of what everything out there. We're just trying to make a scratch in the surface. And like, if you're making that scratch, make a scratch in an area where you're passionate about. So first identify a good problem. I think there's this really good quote by the mathematician George Poela, that no mathematical
Hmm.
education is complete without one trying to solve a problem formulated by them on their own. Right. So try to start, like, even if you start like your bachelor's, you start any research journey, start with a large massive problem which you want to solve. And that problem can be very 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 open ended, or very very right off the bat. But that problem and the motivation to solve that problem will guide you through your research career, is what I strongly
Okay.
believe.
Okay,
Okay.
that's
Yeah.
nice. And actually, can you give us a more clear idea for the as a academia researcher, as a academic researcher, and what is the difference into a industrial research?
Yeah,
So
yeah, I also like to add here. It is a very difference, and many have questions regarding this. Academia research is very different from the industrial researches. So we
Oh, so
would like to
sure. So
know
definitely,
about.
that is true. Yeah. So academic research is much more curiosity-driven research, where you basically have hundreds of domains of knowledge. You can pick any of them. You can become an expert in that. You can have a PhD. You can basically have postdocs in that, and then you can have students and you can train your students in that. Right. And so it's a very curiosity-driven. You tackle big problems. You can also tackle small problems. You can tackle whatever you want to, whatever you think is a very very good problem to solve, you can take and then tackle that, right, in academic research. On the other hand, uh, if you look into like, if you, let's say, on the other hand, if you look at industry research is much more motivated on the application. So it's also much more motivated through finances. So your company, depending upon where they want to put their funds into, they'll be very very defined and scoped problems, that you want to increase the efficiency of this, or you want to improve the accuracy of this particular product, or you want to have this particular problem solved, and all your effort and everything you do is going to be to that particular thing. So it channelizes you, it pushes you much harder, it pays you much better into those directions. But then it basically fundamentally snatches away that freedom and that curiosity driven work. I think some institutions do have that, but like broadly speaking, that is the thing. And in academia, you have this satisfaction of mentoring students, and you have the satisfaction of doing whatever your mind pleases and getting into that. But then the channelization is often not there, and you can have careers which basically end up not being that productive, and you also are not paid as much. So
Yeah,
you have to take your
Yeah,
choose your own poison.
both side
yeah,
pros and
exactly.
cons.
Yeah,
Yeah, exactly.
I like the last best line. You choose your own poison.
choose your own poison. Yeah.
Obviously, like it's a end of the day, end of the decision is just छोड़ दिया आप पे जो करना है करो.
हाँ, एंड आई थिंक
Yeah,
ऐसी चीजें होनी चाहिए, बिकॉज कोई ऐसी एडवाइस नहीं है जो सबके लिए बनी है। सबको खुद जो अच्छा लग रहा है एंड सबकी लाइफ में और जो अपॉर्चुनिटीज उनको मिल रही है उसके हिसाब से जो सही है वो चूज करना
yeah,
True, true, true.
exactly. So, like, is you are first start your journey with some kind of research and then currently work into Google. So, what is your point of view being a research to being a industrial engineer? So, what can be practices or some practical knowledge which you gained by doing a cutting edge practical practices or practical research.
है। if I'm able to understand your question correctly, I think you're talking about like the impact of academic research to then getting into academia, getting into industry and doing not academic research. And I think both of those things are like very, very, very important for me. Like I did a lot of like proper academic research before undergrad, at undergrad, and maybe even at a master's level. And I did realize I learned a lot of principles from that. I learned a lot of how things work, what is important, what is not important. I did a lot of curiosity driven things, but like after a certain point I really wanted to essentially be more channelized and solve problems which are really, really useful to the world. And it became a bit tricky to be in academia and do that. It became a bit tricky to understand what the world wants at a at a dynamic pace, and solve those problems. And so I think to expand my impact and to work with work full time on actual problem solving, I essentially ended up doing industry, getting into industry and doing sort of industrial research, industrial sort of development. And I'm like very happy where I am right now. Very happy where I am.
Yeah, and have you bridge your gap between cutting edge technologies and and some practices?
Yeah, I would also like to add because as we say in India also and many part of the world, I guess there is a huge gap between the industrial works and the academia works. So how can we bridge that gap? If
Also,
you tell our
that
audience, it
that
will be
is
beneficial.
that is a very, very nuanced question. So there is a question at a professor's perspective and a student's perspective. So
Hmm.
if you look at the top universities in the world, the quality of research the professors are doing, the quality of research there is incredibly awesome. So like
Yeah.
I feel the work that happens in academia is much more fancier than work that happens in industry, right? So if you so everybody normally you start from academia, you're doing this quality work, and then you basically have a much easier, a much more nuanced, a much more cog in the machine type of work in industry. So it's a very easy transition from academia to industry. The problem comes when you basically are at a place where the cutting edge, so you're not at the top tier universities in the world, and you're basically at a place where the work that is happening and what you're being taught, more than the work, more than the research, you're not doing any research, you're just taught machine learning, you're taught computer science, and the level at which things are taught is not as as much as what you would actually see in industry and what is actually used in industry. And that is more common in in undergraduate programs, and it's more common as a student's perspective. And like my suggestion there is very, very simple, that if you are into that situation, well and good. Like you get into industry, start doing small things. That is where you have these levels at these big tech companies. You start L3 at Google, you start L4 at Amazon, you start E3 at Facebook. Like all these, you start at those levels, and then you go to L4, L5, L6, etc. And so you talk to people, you get mentored by people, you build things in the company, you understand how systems work, and gradually you're rewarded with promotions, and then you go ahead in your career.
Okay. there is a question like many of my friends also have like they are doing lots of projects and many younger generation would also relate that open source project doing is beneficial for them or just they are doing some private project but that is good enough to showcase what they believe. So can you
I mean,
show a light on this?
showcase 100%. I would say if you do something open source, if you put that out on GitHub where people can tinker with it and people can interact with it, that is going to be very, very useful. I think far more useful than anything you just don't do, which is you put out there. Like if you put the source code, if people go to your GitHub, look at things, download things, that's going to be very, very, and that's going to be very, very.
Under this light mode, can you share some your music preference and in your alone time what you are doing?
Oh, I mean, my music preference, I really, really like to listen to very, very slow songs. I'm one of those people who loves to, understand lyrics of things, and I'm big into like poetry. I like a lot of English poetry, Hindi, Gujarati poetry. I'm big into like ghazals,
Oh,
that kind of stuff.
Okay,
So
ghazal
I'm
is one
quite
of my
prolific.
favorites too.
Oh yeah, ghazals. Definitely, I'm a
Yeah,
big fan of
yeah.
ghazals. I have all sorts of obscure ghazal collections you can think
and
of.
also can you write some ghazal by on like some
Ah,
कुछ
most
habits
of the
होते हैं
machine
तो
learning engineers have side hobbies like writing the poem or writing
No, no,
lyrics in.
I mean, I usually do much. I like to consume a lot of stuff. Like I think I consume much more than I can produce, because for me, I do a lot of like a lot of projects. I'm involved in a lot of committees. I do a lot of projects, and so it becomes very, very interesting. I do a lot of projects and stuff like that. So it's very hard for me to find time to do these things. But like whenever I'm working or I'm in a passive mode, it's consuming. Listening is a much easier thing to do.
yeah,
Mhm.
yeah, that's a nice. So can you please share some roadmap for the uh, dive into machine learning?
The I mean, this is there is a million things on the internet already on this, and there is limited point in reiterating that. But the very simple way of doing a roadmap in machine learning would be, there is like a lot of like I think I can point you out to a lot of resources, but like the basic thing you do is essentially you learn. You basically learn first you'll try to learn the entire pipeline of how basically machine learning works. So first basically you know basic programming, that's the prerequisite. You basically know some mathematics, that is the prerequisite. And then you try to understand like the entire like the process, like basically data collection, data preparation, model training, analysis, deploying, and then trying to do all of this again, right? And so you try to get a high level understanding of the entire pipeline, and then you look at okay, data collection, what kind of things I can do, data preparation, like what are the tools, and then you start looking at like each and every step of the process. You take a toy problems, you take a couple of toy problems, and you start working on them and think about okay, if you want to be do Python based, like most likely if you're doing it the first time, you're going to start with Python. And then if you want to do like Python based machine learning, so you basically look at the libraries that are available. There's a TensorFlow direction, there's a PyTorch direction, like you can pick up anything and everything. And then you try to understand you can look at a lot of concepts. You can look at where to like code, where to good books, understanding like cloud services, good data sets, and good, you have good tools for yourself. And then you try to take each of the machine learning problems, like classification, regression, sequence to sequence, clustering, etc. And then you try to do this entire pipeline, try to learn how you can solve each of these problems through this general machine learning pipeline. And I think this is a very hands-on way of learning machine learning. And in the background, you can be taking a lot of online courses where you are actually learning the concepts and the mathematics behind a lot.
So
So
can you share some good balance between into industry? What is the balance between a software engineer or one machine learning engineer? So how we know?
I mean, that is what I've been like iterating, the fact that the gap is much smaller than what one would want to think. A machine learning engineer would maybe do 60 to 80% just software engineering, what you would term as software engineering, like deploying
Okay.
infrastructure, scaling models, looking at these models, trying to iterate on those models, even in a big tech company, because like the entire model development part. So I think what a machine learning engineer does and a software engineer does not do is like the model fine tuning part, or like in a very, very, very rare cases where you basically actually get to think about new models and think about training new models. So my suggestion is always like, if the difference is minimal, become a good software engineer first who has done some courses in machine learning, who has a good understanding in machine learning. Go to your company, see whether they require what kind of work there is to do. You'll always have to do some threshold percentage of software engineering, and then on the rest of on your plate you can have some core ML related fine tuning or model development work.
So Shivam, in this fast evolving era, how do you keep yourself updated
So
with
this
the
is also
current trends
a
and technologies and
very
all?
very very interesting question. So I basically read a lot of papers. So I there is a couple of nice people you can follow on Twitter. There is things like 2 minutes papers on YouTube, where basically there's like any popular paper comes out, they'll basically do a 2 minute summary on that. So these are some of the, and you always are on top of your game for conferences. So if there is NeurIPS, there is CVPR, ICML, like any of these conferences, there are going to be spotlight papers, there are going to be best paper awards, and they're going to if it's very hard now to go through all the general list of papers, but you at least have spotlights, you at least have those kind of things. You if you whenever you're free, you're commuting, you try to listen to the keynote speakers, you try to listen to the workshop speakers and things like that, which is very
Okay, so one interesting question I would like to ask. If your computer could talk, what would it say after a long coding session?
I have no answer to that question. I think it would just say, uh, good work, come again, because you've not completed your problem. Because oftentimes what happens in computer science
Ah,
is never, code never compiles in your first try, and you keep on trying and you keep on trying. And the most of the times when you say you completed a session, it's like you've given up and you come back next day and do things again.
I
I think
guess
that
computer will say think about me also.
usually, the work culture and the work life balance we have here is really, really good. So it usually
Yeah.
doesn't happen that way, like other than save a
Okay.
few days where we're working very hard.
Okay. Is there one important question or fun not funny, but how much
Icebreaker, you
duration?
can say.
No, no, no. It's like I put some model into training. It takes 2 hour, 4 hour, 8 hours. So what is the longest duration of time for your model you have trained?
Oh,
The
six
longest
months.
s- 6 months training
Yeah, yeah,
continuous.
Okay.
yeah.
Wow.
3 months to 6 months is, yeah, 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 definitely.
Which one
Yeah,
is that one?
that is definitely quite confidential in the company. But like
Okay, it's
when you're
company work,
training
so we
like
can understand.
big, yeah, it is basically if you're training like large systems, places like Google and all, like where you have trillions and
Hmm.
trillions of data points. Yeah, there are models which train in 8 hours, and then there are models which will basically take multiple days to train, and there are models which have taken 3 months to train. For sure, I think the largest one, I think largest model I've trained is 6 months.
Oh,
Okay.
uh, I
So,
guess and I and Charul were working in similar area, machine learning area, but I guess we have touched 4 to 5 days only.
Yeah, yeah, that is
maximum like 5 days is enough. Like
yeah,
That's
one
our
makes
hour
sense. Like,
maximum.
training.
yeah, that's. I mean, the point is that yeah, depending on the scale of the problems, the number of users, the large,
Yeah, yeah,
we
yeah.
basically our models themselves measure in terabytes. So, like the
Yeah,
size of
exactly.
models usually go like the data sets, like you have like terabytes of data to train on, so
Yeah,
or
exactly.
petabytes of data sometimes to train on. So yeah, it takes
So,
some
is
So,
there any machine learning project that you are proud of, that you even today, that you can stand and say, okay, I had built this one?
No, I think there's too many of them. I love the problems I work on, and I think there are there are some problem projects I'm really proud of, and there's some I'm not. And I think it's a much like I think it is a very open question who you ask, and who my projects have been useful to. So I think I'm happy almost in what things I've been making. I'm very excited for what other things I'm like gradually building incrementally. And so it's very hard
yeah.
to pick one project.
Even though you have to pick one, then which one it would be?
No, no, I
One or
would
two.
definitely, as I said, it's not that trivial to pick up because there is, as I said, like depending upon like whether you're a biologist, there is a different thing. Depending upon like what domain and what things you're working on. Like I mean, I did like a lot of like the deep reinforcement learning projects I built uh, in my undergrad, and like they had like
Mhm.
vast applications, and like I still like to do a lot of multi-agent RL. But once again, like it's a good, interesting trade-off between uh, what is
Yeah, yeah.
important
And
Okay.
and
Yeah,
to
and
Chalo.
who.
okay. And could you have to meet one tech visionary guy? So what will be the first question you ask them?
Oh, which visionary guy is the question?
Basically a good uh, we all have our some idol kind of stuff for the our field. So if uh, you you get a chance to meet them, so what is the first question uh, you wanna
I
ask?
mean,
To
Yeah.
I mean,
your
like
idol, I guess.
like I mean, there's a lot of people I idolize in machine learning. There are way too many people like that. But let's say if
Like
I
I
ask
we
some
can say
really really,
Andrew or Elon Musk, if we say.
Elon Musk is not a machine learning engineer.
It is a
So
CEO of, but we can say Andrew NG. He's working very good in that
okay,
domain.
let's say meet Professor NG like once again
Huh.
now, and what question I would want to ask him. I
Or
just
Sundar Pichai you meet. You are at Google also.
I mean, see, that is, as you said, these are very, very different people with like, one of them is basically a machine learning scientist, and the other two people are like CEOs. And the question you ask the CEOs is very different than the questions you ask to a machine learning engineer. And I think the first question I would want to ask to a very, very senior machine learning researcher is, what do you think about, ethics in AI, and what do you think about like, AI policy? And I think there's a similar question I would basically want to ask, even the CEOs about like AI governance, and where do you think we are going with these things? Like, how, like, like the conversation of how close we are to AGI. Like, since everything is very open source, there's not a lot of things researchy which they would know much more than what the general public would know. But like one thing we are very curious to understand is like, where is the AI? Where are we thinking about AI governance? Where are we thinking about AI ethics? If there are driverless cars, if there are the world is governed by AI, like where do we draw a line? And like where do if AI is replacing people's job, like how do you sustainably grow AI? And the questions around regarding AI policy and AI governance is something I'll be very curious to know from a top machine learning practitioner, and maybe for a CEO, like trying to understand like how they are imbibing those principles, and how they think the future and the products they're going to build in their companies are going to be imbibing those principles, is very, very interesting to me.
So just based from your answer, I just want to ask one question. For the model training or for the model insights, we just call as a transparency. So on that point, what Google is working for the make more transparent model.
I
Spoiler alert.
definitely can reveal what Google is working. You can read the Google has a huge bet on like open source. As you know, Google has a lot of bet on like making open source models, making models readily available, making smaller models, making models which are fine tuned to specific domains which are available. So Google does a lot of put a lot of effort on fairness. Google has a lot of campaigns going so that the data what gets into these models are really, really diverse. And there is always like, if you look at any products like Bard and all, there's a lot of feedback, imminent feedback, that Google expects depending upon the output the models generate. So I think internally there's a lot of really, really solid work coming out on AI transparency, on like making models more robust, making sure that there is fairness, making sure the models doesn't is not biased to a specific segment or specific demographics of the world. I think there's a lot of really interesting work that's going.
Yeah,
Okay.
and
Hmm. Yeah,
just
Chalo.
how the Google prioritize the ethical issues while developing some products. Basically,
I
some
mean,
machine learning or deep learning kind of stuff.
like if you want to look into like Google basically has a code of conduct. If you can go to the website, the Alphabet Investor Relations. If you when Google also if you go to Google AI website, Google has like this responsibility over principles, and there's this objectives for AI applications which are like openly available, where we try to be socially beneficial, avoiding or creating reinforcing unfair biases. We build for we build and test for safety, we be accountable to people and a lot of other things, and we uphold high standards of scientific excellence. And there are also a list of AI applications we will not pursue as a company. And so you can just go to the Google AI website and look at the responsibilities and the principles.
Okay, so is there any technology that is going to be happen in few next 25 years or 30 years that could entirely change the world? Like we are talking about the robots and flying cars or anything just like that
I mean, your
from
guess
your
is good as
perspective.
my guess. I think AI is gonna be AI is gonna definitely gonna be a very important part of our lives. I think the rise of Internet of Things and like Wi-Fi and everything and every device communicating itself is gonna be very, very massive. We're gonna have like foldable screens and things like that, which you already see. So things very,
Hmm.
very portable devices, which are we're gonna talk about sustainability, and I think we're gonna have a really dependence on solar and everything will increase if you think have like things like foldable solar panels and things like that. That'd be very, very interesting thing to have. And so I think there's a lot of technology. I am very bullish about in like the for the future, that we have a lot of problems in our our lifetimes which we have to solve. And there are a lot of potential solutions in healthcare, in in climate, in just the world in general, in governance and in accessibility. And I think gradually by bit and bit we end up solving those problems. So,
Okay, so there, I would just like to ask one thing. Like, there has been a turning point in everyone's life, like fall down and rise ups. So, what are your turning point in your life? Like, when did you get the failure, and how did you rise up from that failure?
I think there have been many times in my life where we've felt very, very down, things not working
Hmm.
out, internship applications not working, grad school applications not working the way you want them to work. And like we live in very challenging times, we live in very competitive times. The only thing you tell yourself is that you definitely are not entitled to anything, and whatever you have achieved is basically an accumulation of advantage, a lot of combination of luck and some hard work. I think far more luck than any hard work could have ever made you where you are. And so you try to remain grounded, and you try to look at opportunities, and you try to look at the brighter things in life. You try to look at those opportunities, uh, um, like which are there on the table rather than the opportunities that could have been there. And then you try to grab those opportunities and try to convert them into good ones. I think that is the uh, right way of doing
Okay.
Okay, so mm,
Yeah, Charul.
Shivam, we have one audience question kind of stuff intersection. So there is a Namya here as the audience. She want to ask some question to you.
it. Sure.
Yeah, Namya, please.
So, I would first ask a very typical question. I'm a BTech student right now, right? So, for going into Google is one of the, like things that many BTech students do aspire for that. But I just wanted to ask that many of people keep emphasizing on competitive programming. But I
Mhm.
have somehow, like, I wanted to connect that. How is competitive programming? Is it crucial for machine learning as an aspect?
Um,
It is very nice question.
so
Okay.
no, I think this is a good question, and I want to really honestly answer this question. So, do you say that how is computer coding useful for doing a day-to-day machine learning job, or how is competitive programming important to get into a machine learning job? They are two different questions. What do you
Yes,
ask?
yes. So I think I have both of them. But I was asking, trending to ask the first one that you said that how it is important to get into a machine learning job.
Oh, so that 100%. So there is no other answer to this question, and I would want to be very, very clear to this, that competitive programming is the most important thing you're gonna encounter in your computer science career. If you want to make a career in technology, in right now the way the interview system works, and it's a very robust, it's an awesome system that you use. They're gonna ask you competitive programming. Like no matter you go to a big company, you go to a medium-sized company, you go to a small company, they're 100% gonna be a competitive programming questions, right? I think it is extremely crucial. I would say it's like I have seen things change in my life. I've seen machine learning become famous and become what it is. I've seen trends. I've been in programming since almost the last 13, 14 years. I've seen things rise up, things come down. I've seen all sorts of changes, and everything I've seen, one thing I've the one thing that has remained constant is the fact that the person who's good with computer coding is successful in computer science. 100% true. Like at least they'll have like good jobs, at least they'll have some role to go to. Computer programming is one of the most important things you do if you want to get a good job in technology. Like, you have these things that, you should have like, 5 almonds a day or something like that. Like my suggestion to everybody is don't have 5 almonds a day. Instead of that, do 5 competitive programming almonds a day. That is going to go a long way, right? And the reason why competitive programming is so important is that when you're basically sitting down here and looking at, like, on the other side of the table, asking people, interviewing people, there are a lot of people in machine learning who are gonna, or in computer science, who are gonna have a math background, the people who are gonna have an economics background, the people who are gonna have a finance background, the people who are gonna have any sort of background. And if you ask them core computer science questions, it's be very unfair to them, right? And so you ask them logical questions. You don't need people who have a deeper understanding in networks or something like that, at least at the junior level. You need people who have a good understanding of logic, people who are sound problem solvers. And if you bring in a bunch of sound problem solvers, you teach them technology, you basically, they're going to excel well. Because if you take an interview of some specific technology today, 5 years down the lane, that is not going to be relevant. And then what candidate did you hire? Instead of that, you take interview of a person who is logical, who basically knows how to solve problems. And that, I think, is very, very robust. And that is the importance of competitive programming. It's very, very important. Any company, Google, Apple, Microsoft, small, big, all of them are going to ask you competitive programming. And if you feel that, I think this is one of the biggest myths. I think it is not a very good thing to do, but like, it is one of the biggest myths that is going across India and a lot of undergrads around the world, for that matter, that, people who want to get into software engineering jobs should do, machine should do competitive programming. People who want to get into ML jobs need to do ML, or people who want to do their MS outside need to, do ML. Do not get into that at all. Like, if you want to become an ML engineer, still most of the companies are gonna ask you competitive programming base. So 100% strongest advice, if you don't do anything, do be good with competitive programming. Base level, right? If you're good with competitive programming, you have a far, far higher chance of being successful. No matter, you get to the US, you go to Canada, you go to any country, you have far, far higher chance of being successful.
Yeah, that is
Oh,
actually very
okay.
clearing. You mentioned about that. That was exactly the myth that mostly goes around in the BTech, that if they are interested in ML, then there is no need for competitive programming. So
And
yeah.
if you fall into that, I've seen people getting into that myth and having a much, much harder struggle out of getting the jobs they like and things like that. Why get into that when you clearly know the answer to these questions? I think competitive
Yeah.
programming is the most fun. If you want to do any job related to computer science, ML, you go to any world, you need to be good with computer.
Okay,
Period.
so I have another question that you mentioned during the talk before that ML is something that everyone are doing right now because of how
Mhm.
prevalent it is in all the fields. So what I wanted to say that since everyone are having in their skill set that okay I can do machine learning, how do you think that someone who is genuinely and very good in machine learning can set himself or herself apart from those like the people who I shouldn't, but like I would say are the people who are actually just applying the models, but they are not actually doing the core machine learning.
So the sad reality of life is that, for the most part, as I said, the it's an extremely saturated field. Extremely saturated. Machine learning is, no matter machine learning development is an extremely saturated field. No matter what anybody else will say, like, in my humble opinion, like, machine learning is an extremely saturated field. And like, if you want to be that person who develops model, if you want to be that person, the amount of jobs for that model developer are far, far less. For every, let's say, 100 jobs in machine learning, I think 2 jobs will be for the person who sits down and does the model development. 2 jobs. And I'd say out of 100 jobs in software engineering, 5 will be of machine learning. So if 5 you magnify it to 100, and that just to are basically the person who develops these models. And so my suggestion to you is that if you feel you are, it's a very hard bet to make that you'll get into those very few 2 positions, right? So it's a very hard bet to make. So if you feel that you basically are very, very passionate and you want to do that, uh, It is just that you have to work incredibly hard. You basically have to get good publications out, get a good newspaper, get a good CVPR paper, like get good conference papers out, uh, do really, really good applied internships where you actually work for companies where actually you're doing model development, and then incrementally have good papers, go to a nice graduate school where you actually publish more papers, and then come to maybe do a PhD. Most likely, I think PhD will be necessary. Get into a reasonably good PhD program, do the research required, publish quite well in good venues, and all these things like are you can't like start with at a PhD. You have to start at a BTech level because PhD is the barrier to entry is really, really high. So you do that, you become successful, and then you try to get into those two positions which are you at least not even getting, you have a shot at those two positions. It is so competitive right now.
Yeah.
Yeah.
And
So
if
just
and it's,
one.
oh,
Yeah.
huh, go on.
No. Please continue for the last part.
No, so I think my suggestion always is that if it's a much easier thing to do, and it's a much, for the most people, I would say it is a much more feasible journey to become the person who applies these models, and then the person who actually gets to make these models. And there is nothing wrong. I think the other thing is that this prestige angle that is basically common in Indian undergraduate circles and even on Indian grad circles, that machine learning engineer position is a somehow a higher and a more desired position than a software engineering position, and this becomes even more rampant in like internship situations where people are like ML intern and SWE intern. And I mean, it is a very, it's not a smart thing to do at all. Like the amount of software engineering positions in the world are far greater than the amount of machine learning engineering positions. It's super competitive to get into machine learning. If you're getting good software engineering positions, nothing like it, go grab them. I would definitely suggest that to a person, because every undergrad I talk to, like I've seen, I'm tired of looking at resumes, like 1,000 resumes. All thousands resumes will have just want to do machine learning, will be passionate about machine learning. If you look at their projects, all even like if you look at BTech students right now, all the projects they have is machine learning. There's like not even a single project which is not machine learning. You ask people what programming languages after they graduated, and they're like, yeah, we just know Python. And like they're like, yeah, we might have done some course in Java, but all we know is Python. And this is the exact
Hmm.
problem, this is the exact saturation that the industry faces, that we have too many people, way too many people who want to do machine learning. And
Yeah,
that
and
is
that could
where
lead to layoff as well.
not only layoffs, like the literally people, like those people who just wanted to do machine learning end up coming for the masters, and then they realize that, yeah, we don't have the jobs we ever wanted, and they end up getting a software engineering job. So had they understood this earlier, they would have done the relevant internships, and they would basically have gotten a much better opportunity in software engineering, right? So my
Yeah.
suggestion is that identify your profile, identify what you're doing. If you are into something super competitive, and if you feel that yes, you are in that top 0.1% who's anyway going to make the cut, sure, pursue it. You might stand a chance. But if you don't, then my genuine suggestion is to be very good with competitive programming, no matter where you are. And then pursue opportunities, get into domains, get passionate about things which are still manageable to do, right? Which still are not that
Yeah.
competitive, and then try to make your career. There's a much wiser, much simpler way than,
Yes.
competing.
So, just a last question. During the talk, you also mentioned that we talked about explainable AI. So, I just wanted to ask that how is you also mentioned about debugging an ML model, and you talked about explainable AI. So, I was just trying to find a difference. Like even in the debugging part, we are actually trying to figure out that why a certain decision was made or what went wrong. And explainable AI is also focusing on the interpretability of the aspect of the machine learning model. So are they to go do they go hand in hand or are they completely different?
I think they're drastic. Like, I mean, there is definitely some overlap, but I would say that model debugging is a very different process than explainable AI. Model debugging might not even require those things. Model debugging is just trying to understand like, and it's like it's much more traditional. It's much more like explainable AI is all good to have, but we don't have mature explainable AI systems. Let's say you have a very huge pipeline where you, so it's not just the model. So the key thing is that it's not just the model, it's the entire data ingestion pipeline, the entire deployment setup, the making of the prediction, the scaling of the predictions, like all of those things. Like anywhere things can be wrong, the model itself can be wrong, the model can be over predicting due to multiple reasons. You need to try to isolate those reasons by manually removing things, trying to understand, like like model interpretive model externality can be one tool you can use for like debugging the models, but it's a much more general thing where you have a lot more lot other of other aspects to this as well, than just just the model and the model interpretive part of it, simply because we don't have that mature like ideas and that mature techniques to do model explainability at this point in time. And it might not only be a model problem itself, it can be a much more different problem.
Yeah, like
Okay,
including being inclusive, model being inclusive, and being dependent on that. So, yeah, that's correct. I
Probably
think that gave
that's
a
a good
pretty good
that
response
was
to that.
later
very nice questions from our audience, Namya. So, is there anything,
Thanks,
Shivam,
Shivam.
would you like to add on which we could have missed, but you would like our audience to let know?
No, I think the only thing I would want to add here is that just the fact that, you know, machine learning is very, very cool and there's always new things coming up. Like, stay curious, stay learning, but also realize how competitive and saturated it is. And it is very, very, I think there's this, as I said, there's this entire thing that's going on that ML engineer is fancier than a software engineer or like any other role. And like, I mean, try to dispel that myth. There is nothing fancy, there is nothing like that. ML engineer is just one engineer who tries to apply machine learning to the problems they're given at hand. And I mean, there is no inherent like, it's like somehow at a university level it is shown to be this very fancy, very, it apparently isn't. And like, I think you should be as much of a good generalist as you must be a specialist. Like, yes, you can specialize in machine learning, but tomorrow you might not be, there might not be any machine learning. There might be something completely different. And so good software engineers, good engineers in general who know how to build systems, scale systems, are going to last much longer than any other specialty or any other sub-specific thing in the industry in the time to come.
Yeah.
Right. So
And like just we conclude this entire conversation into one question. So, what is the takeaway notes you want to give to our our audience from this entire conversation?
I think my key takeaway note is just that stay curious. There's a lot of opportunities out there. Try to my only thing is that try to look at the problem and the solution. Don't fixate yourself on the tools. So I think machine learning is one tool in your toolbox. Don't go with machine learning and say what problems I can solve. Go understand the problem and say, okay, what tools I can use. I think that is very important. Don't fixate yourself to that you want to do just ML or you want to do this thing. Just try to think of things at a problem level, right? And overall, once again, lead code competitive programming is one of the most important things you can do in your computer science education. Yes, understand the basics well, understand your mathematics well, statistics well, but missing competitive programming can basically lead to your life becoming you playing your life from easy mode to hard mode very, very easily. So, you know 2 to 5 competitive programming problems a day, no matter what happens, no matter what day it is, that is an ideal thing to do. Everybody in the field should.
Yeah, that's
Okay,
nice advice.
this
Advice to the for the listener.
hmm. So it's been inspiring and very motivational and very meaningful talk from you. So we will end this session here, and it's pleasure to have you, Shivam.